To get the game up and running quickly, we're going to work on the 3 methods required to launch some fireworks. Did move to view will create a timer that launches fireworks every 6 seconds. CreateFirework will create precisely 1 firework at a specific position, and launch fireworks will call CreateFirework multiple times to create spreads of fireworks. First, the easy stuff. We need to add some properties to our GameScene class. First, we'll add a property called GameTimer, which will be a timer. We'll use this to call the launch fireworks method every 6 seconds. Second, the fireworks property will be an array of SKNode objects. Fireworks, like the penguins in Project 14, will have a container node, and inside that other nodes, in this case an image node and a fuse node. This avoids accidental taps triggered by tapping on a fuse of a firework. Third, the left edge, bottom edge and right edge properties are used to define where we launch fireworks from. Each of them will be just off screen to one side. And finally, the score property will track the player's score. I'm going to give you a did set property observer, but leave it blank for you to fill in later. You should know how to do a score label by now. So let's add some properties now. We can say var GameTimer is an optional timer. Var fireworks is an array of SKNode. For left edge, we're going to say that is -22, just off the left edge of the screen. For bottom edge, that's also -22, off the bottom edge of the screen. And the right edge is going to be 1024, so the right edge of the screen plus 22. So just again off the screen. For the score, we can say var score is 0, with did set, our property observer, and then your code here. You want to fill that in so you've got a label node that changes its text whenever the score interchanges. To get the whole thing moving, we need to put in a background picture, the same way we put in all the background pictures so far, and start up our timer object. In our case, we're going to have it call launch fireworks every 6 seconds, with repeating enabled. We haven't written launch fireworks yet, but don't worry, we'll do that soon enough. So inside the move to view, we'll write this. Let background is an SK sprite node with the image named background. Background.position is CG point of x512, y384. Background.blend mode will be .replace because background.ping, our background picture, is totally opaque. Background.zposition, we'll do -1, that's behind the rest of the things in our scene. And add child background to add it to the game scene. As for our game timer, we'll say game timer is a new timer.schedule timer. We're going to use the time interval user info option, this one here. Time interval will be 6 seconds. Target will be self. For selector, we'll say hash selector launch fireworks. Again, that doesn't exist yet, but that's okay. User info will say nil. Repeats is true, so it'll fire again and again and again to keep our game running. And that timer will carry on repeating until we tell it to stop, which in this project we won't. That'll be your job. Each time a timer fires, it'll call launch fireworks, which itself will call a different method called CreateFirework. Initially, we're going to write 4 types of fireworks spreads, i.e. different ways of launching fireworks. First, let's take a look at the CreateFirework method. This needs to accept 3 parameters. The x movement speed of the firework, plus x and y positions for the creation of the firework. Inside the method, there's a lot going on, so we'll walk through this slowly as we go. First, our main method signature, func CreateFirework, with an x movement value of CG float, plus an x position int and a y position int. This is our main method to make exactly 1 firework. The first thing we're going to do is create an SK node that will act as a firework container, because inside that will be the sprite for the rocket, plus a particle effect behind it like a fuse. So we'll create that thing inside here, then place it at the position that was specified. We'll say let node is a new SK node, node.position is CG point, x is x, and y is y. So place it wherever the method was called with. The second thing we want to do is create a rocket sprite node, give it a name firework, so we know it's the important thing in our game. We'll also adjust its color blend factor property so we can color it, then add it to the container node. Now, color blend factor allows us to tint sprites in different ways. In our case, that means we can create different colors of fireworks to add some challenge to the game. So we'll say, let firework is an SK sprite node with the image named rocket. Firework.color blend factor is 1. Firework.name is firework. And node.addChild firework. So these are the same rocket picture for all the fireworks in the game, but prepares to color them. And this means color it by the full amount of whatever color we specify. There's no color there, that comes in a minute, but it does right now at least say, please make them all fully colored by whatever color we choose. Name it firework, then add that thing to our node, our empty node, that will hold the full firework, including its fuse behind it. So as the rocket moves, the fuse will also move. Now, just using color blend factor 1 says we want to color this thing fully by some color, but doesn't say what that color should be. That comes now. We're going to say next, make a new random number between 0 and 2 inclusive, choosing either cyan, green, or red for the color of the thing to create. By the way, I've chosen cyan rather than blue, i.e. pure blue, because pure blue isn't particularly visible on the sort of starry sky background picture I've chosen for this game. So we'll start by saying switch int.random in 0 through 2. If we got back 0, we'll do firework.color is cyan. If we get back 1, we'll say firework.color is green. And for all of the values, which should just be 2, we'll say firework.color is red. It's either going to be cyan, green, or red firework made when we call this function. Next up, we want to fire this firework in a particular direction. Now in this case, we're going to use a new SKAction called follow, which lets us specify an exact path to follow. This could be a straight line, it could have many curves. It's our path to choose however we want. And this is really useful because we can say start the path at the start of the firework at its current position, move it in some direction, i.e. our X movement being passed in, plus 1,000 up, so it'll go off screen at the top. But then, most importantly, we can ask SpriteKit to orient the rocket to follow its path. So it'll always point forward along the path as it moves. First we'll say, let path is a new UIBezierPath. This is a UI kit type for drawing these kinds of paths. Again, could be straight, could be curves, could be all sorts of shapes. We're going to start by saying, move this thing to the 0 point, which will make it start where the rocket starts. So we'll say path.move to .0. Then path.addLine to CG point. X is our X movement, which could be straight up the way, like 0x movement, or to the left or to the right. And for Y, we'll say 1000. So regardless of X movement, always move very far up the screen. So that creates the path we want this thing to follow. We can now make it follow that path by saying this. Let move equals SKAction.follow. Like this. And there are a few varieties here. The best one to choose is speed, not duration. Duration fixes an exact time, like does over 5 seconds. Speed lets us say we don't care how long it takes, but here's how fast you should move. So I'll use speed. Our path will be our Bezier path .cg path. That's the underlying CG path value for our UI Bezier path. This is the core graphics path version of that thing. This is used because SpriteKit exists on Mac OS, on watchOS, on tvOS, and iOS. So they can't have UI Bezier path. That's a UI kit type and therefore only available on iOS. For as offset, we'll say true. So we'll start where the sprite starts and move from there relative rather than absolute values. For orient the path, we'll also say true. So it will follow that direction it's pointing as it goes. It will turn to follow the path always. It'll look really nice. And for speed, again, trial and error. I found a speed of 200 looks great. It's the right kind of speed for this game. So that creates a follow action. And we can now tell the node to use that action, to follow that path by saying node.run move. Start following that path now. So that creates the firework sprite and makes it move. Our next job is to add an emitter node behind it using this fuse.sks file. That's a particle system I designed to look like sparks coming off the back of a firework. So we're going to create one of those, position it just behind the firework node, just below it, and add that to our same SK node. So we'll say let emitter equals SK emitter node with the file named fuse. And you can force something up there here if you want to, or instead if you want to be really safe, even though it's in our bundle, we could say if let emitter like that, whatever one works for you, I don't really mind. Then do emitter dot position is CG point with the X of 0 and the Y of -22. It's a little bit behind the rocket. And add that to our node. Boom. And finally, that's our full firework created. We want to add that to our game scene and to our fireworks array. So we'll end the method by saying fireworks.append that node and add child that node to add it to the game scene and add it to our fireworks array. Now there's a lot of new code in there, but just to recap briefly, the coloring process, the way of tinting these fireworks sprites, is done using two new properties. One is color blend factor and one is color. These two show off a simple but useful feature of SpriteKit, which is the ability to recolor your sprites dynamically with absolutely no performance cost. So our rocket image, our raw rocket image, is actually white. But by giving it this .red color, with color blend factor of 1, it'll become pure red. If we had a color blend factor of 0.5, it'd mean half red, half white. Next comes the launch fireworks method, which will launch fireworks 5 at a time in 4 different shapes. As a result, this method's quite long. It needs to call CreateFirework 20 times. 5 fireworks, 4 shapes. But really, it's not difficult at all. So let's start by writing @obj_c func launch fireworks. As a reminder, the @obj_c is needed because we're using the selector from our timer. Now we're going to start this method by defining how much fireworks should move when they're moving very steeply from left to right or right to left. As a shared constant, so I'm going to write the same number again and again and again. So we'll start with let movement amount as a CG float be equal to 1800. And that magic number there, again, it's trial and error. I've tried out various numbers. I've seen what looks good. If you want to change that, by all means, just try them all out. See what you think works best for your game. And next, we're going to make a random number between 0 and 3 inclusive, because we're making 4 different kinds of fireworks spread. So we'll say switch int.random in 0 through 3. And if we're case 0, we're going to fire 5 fireworks straight up. If we're case 1, we're going to say fire 5 in a fan. If we are case 2, we'll say fire 5 from the left to the right. And for case 3, we'll say fire 5 from the right to the left. So that's the plan here. And doing that means calling CreateFirework again and again and again with different kinds of parameters. So I'll just go through that quickly now. For going straight up the way, it's easy enough. We can say CreateFirework. X movement will be 0. Don't move left to right. This is straight up. For X, we'll say 512, i.e. middle of the screen. And Y will be our bottom edge. That's off the bottom of the screen. I'll then copy and paste that a few times. Boom, 5 times. Always X movement 0. For the X position, first one is 512, so in the middle of the screen. Second one will be -200, off to the left. Next one, -100, a bit less off to the left. Next we'll have +100, a bit to the right, and then +200, so way off to the right. Otherwise, the same bottom edge. For case 1, we're going to say Create fireworks several times over. Boom, 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 boom. Like that. Now this time, we're firing 5 in a fan. So it's going to fan out from the middle outwards. So we have to have some X movement here. The first one will be 0, go straight the way up. Second one, minus 200. Go off to the left, then minus 100, a bit off to the left, then plus 100, and then plus 200. So way off to the right. For the X position, we're going to say 512, then 512 minus 200, 512 minus 100, 512 plus 100, and 512 plus 200. And bottom edge for all of those things. So there's a fan here. This will start in the middle off to the left, going way to the left, middle slightly off to the left, going slightly to the left, and so forth. They'll fan out really nicely on the screen. We have our next case from left to right. So I'll paste in CreateFirework a few times. These ones, now we can't use X movement 0. We want to use X movement of our movement amount constant. This thing up here, 1800. So they'll all move the same distance left to right. But we're going to create them at different Y positions so they have this whole movement of left to right in a group. So we'll say for our X movement is movement amount. Here and here and here and here and here. So they all move in the same amount from left to right. For X, we don't want in the middle of the screen anymore. We want on the left edge of the screen. So they exist on the left edge and will fly in from there. Like that. The thing that changes is the last thing, the Y position, that's going to be where we create this thing. So the last one will be on the bottom edge of the screen. Second one will do, second to last one, sorry, will be 100, then plus 200, then plus 300, then plus 400. So created up the screen, all on the left edge, moving left to right. For the last type, moving right to left, I'll copy these last 5 CreateFirework calls and paste them all into case 3, because it's very, very similar here. Now our X will be right edge rather than left edge, like that. So off the right edge of the screen, but it should move to the left. So rather than saying movement amount, I'll say minus movement amount. So move minus 1800 rather than just positive 1800. As for the Y positions, they can stay the same. Now, this is not an exhaustive switch right now. It's any kind of integer. We're only covering cases 0, 1, 2, and 3. I'm going to add a default case at the bottom and just call break immediately. Do nothing. That's for you to fill in later on with different kinds of firework layouts. Now, all being well, I can press Command R now to build and run our code. This should actually work nicely. The timer should fire every 6 seconds, creating new firework displays in random layouts. Let's find out. Go in landscape. Hopefully after 6 seconds, fireworks. Let's find out. Boom, there we go. You can see behind it the particles looking nice. That one's going straight up the way. Another one straight up the way. You can see the tinting looking quite nice, by the way. Come on, a bit of variation. There we are, right to left. Super nice. Oh, that's a fan spread there, going out the way. Really nice. Okay, so you can see it's all working nicely.